Today we are looking at another type of progression, and this is geometric progression, popularly called GP. We shall refresh our memory on some key facts of geometric progression. In general, a geometric progression is of the form a, a arrow squared, a arrow cubed, and then ellipsis a arrow raised to power n minus 1. The a here is equal to the first term of the sequence or the progression. The arrow is a common ratio, and this arrow is calculated as follows: the second term over the first term, or the third term over the second term, or the fourth term over the third term, etc. N is the number of terms of the sequence. Geometric series. This is the sum of the terms of the progression. That is a plus a arrow square plus a arrow cube plus ellipsis plus a arrow raised to power n minus 1. The addition of each term of the individual terms is called the series, the geometric series. We are going to be looking at 1. The n term of a geometric progression. How do we find the n term of a geometric progression? We use the formula un equal to a times r raised to power n minus 1. I am using u here to differentiate it from tn, which we use for arithmetic progression. It does not really matter, but just for nomenclature. Now we also look at the sum of a geometric progression. We have two formulae for the sum of a geometric progression. The first one, 2 here, is the sum of n terms is equal to a into r raised to power n minus 1. Please, n is not n raised to power, not r raised to power n minus 1, but r raised to power n minus 1 all over r minus 1. This is when the value of r, which is the common ratio, is greater than 1. The second option is the sum of n terms equal to a, the reverse is the case now, 1 minus r raised to power n all over 1 minus r. This case is applied when r is less than 1. Now, we look at the sum to infinity of a GP. The formula S infinity, this symbol is infinity, is equal to a all over 1 minus r. I want us to note, you cannot find the sum to infinity of an arithmetic progression. So that was why when we were treating arithmetic progression, we did not look for the sum to infinity. Let's take a look at some examples. The first one is 3 consecutive terms of a geometric progression are given as n minus 2, n, and n plus 3. Find the common ratio. Your solution, the common ratio arrow is n all over n minus 2 is equal to n plus 3 all over n. If you cross and multiply, we have n squared is equal to n minus 2 multiplying n plus 3. This will give you n squared plus 3n minus 2n minus 6. Collecting like terms, we have our 3n minus 2n will give you n minus 6 is equal to 0, because n squared minus n squared will be 0. Therefore, your n is equal to 6. So we are asked here to find the common ratio. So the ratio will now be equal to your n, which is 6, all over 6 minus 2, and that is equal to 6 all over 4, and the common ratio is 3 all over 2. Some can write this 1 over 2. Whichever one, this is correct, this is also correct. Example 2. Find the sum of the first 5 terms of a GP whose first term is 3 and its common ratio is 1 over 4 to 4 significant figures. We are talking about finding the sum. And since the common ratio R, your solution will start like this. Your arrow is equal to 1 over 4. It therefore means that arrow is less than 1. In that case, we use the formula Sn is equal to A into 1 minus arrow raised to power n all over 1 minus r. Now, your n in this case is 5. So we have S5. And our first term is 3. We have 3 in place of A. Then we have 1 minus arrow is 1/4. And this raised to power 5. Everything here all over 1 minus our arrow here, which is 1/4. You will now solve this. You will have this as 3 into 1 minus 1 all over 4 raised to power 5, because 1 raised to power 5 is 1 all over 3/4. Now this will give you 3 multiplying 4 all over 3 into 1 minus 1 all over 10 to 4, which will now give you 4 into, if you subtract this from this, you will have 10 to 3 all over 10 to 4. And of course, this will become, if you multiply this out, you will have this as 4092 all over your 10 to 4. If you now use your calculator, you divide it by this, you will now have 3.9969092, and because we are to correct the answer to 4 significant figure, 1, 2, 3, 4, we have 3.996 to 4 significant figures. And that is the solution to the problem. Example 3. How many terms of the series 3 minus 6 plus 12 minus 24 plus ellipses are needed to make a total of 1 minus 2 raised to power 8? Our solution, A here is equal to 3. Our R here, that is the common ratio, is minus 6 all over 3, which is equal to minus 2. And that means R is less than 1. So we use the formula Sn equal to A into 1 minus R raised to power n all over 1 minus R. You have already been told that the sum of the n terms is 1 minus 2 raised to power 8. Our A is 3, and we have 1 minus the value of R is minus 2, all raised to power n. And then everything here all over 1 minus 2. So that this will be equal to your 3 into 1 minus 2 raised to power n all over 1 plus 2, which is 3 into 1 minus 2 raised to power n, everything here over 3. This and this will cancel. You still remember that we have this to be equal to that. If you now compare the value, we have 1 minus 2 raised to power 8 is equal to 1 minus 2 raised to power n. Now 1 is compared to 1, okay. The minus is compared to that, okay. So you are left with 2 raised to power 8 is equal to minus 2 raised to power n. But because the 8 here is positive, then the minus raised to power n, which is also positive, will be equal to 2 raised to power n. Therefore, your n is equal to 8. Obviously, it's because the power here is even. Therefore, if you raise a negative value to an even power, it will also be what? Even. Hence, we are able to conclude that this is equal to this. So our answer, the number of terms we are asked to find, is n equal to 8. Example 4. The third and the sixth terms of a GP are 5 and 125 respectively. Find the common ratio of the GP. Solution. In solving this problem, let's take the third term. Well, the third term is actually equal to a r squared. And so we now have that a r squared is equal to 5. This is your first equation. Then the sixth term is actually, let's say the sixth term is equal to a r raised to the power 5. So we can have our a r raised to the power 5 is equal to 185. So this is our second equation. Now, usually in geometric progression, it is easier to solve this simultaneously by dividing the left-hand side by the left-hand side of the equation and the right-hand side by the right-hand side value of the equation. So in this case, I'm going to divide the equation 2 divided by equation 1. So we take the left-hand side of equation 2 divided by the left-hand side of equation 1 is equal to the same scenario here applies all over 5. Now, by the laws of indices, remember that a and a will go. By the laws of indices, this becomes a raised to the power 5 minus 2. You can divide this now. 5 into 13 is 2, and that is 27. So you have r raised to the power 3, and 27 can be written as 3 raised to the power 3. Since their powers are the same, then their base numbers are the same. Therefore, r is equal to 3. And this is the common ratio of the geometric progression. Example 5. Find the sum to infinity of 1, 9 over 10, 9 over 10 squared, and 9 over 10 cubed. Ellipses, dot, 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 and so on and so forth. That is the meaning of that. Continues in that same order. Solution to this problem, we are looking for the sum to infinity. And so we first of all find our A is 1. Then we also find our R here is 9 all over 10 divided by 1, which will remain as 9 over 10. So the sum to infinity will be equal to our A all over 1 minus R, and that becomes 1 all over 1 minus 9 all over 10. This is equal to 1 all over 1 over 10. And the result is 1 times 10 over 1. And the final solution is 10. So the sum to infinity is equal to 10. Exercise. Question number 1. If k plus 1, command 2k minus 1, and 3k plus 1 are 3 consecutive terms of the GP, find the possible values of the common ratio. Option A, 0, 8, B, 1, 5, 3, C, 0 minus 8, D minus 1, 5, 3. Number 2, find the n term of the progression 27, 9, 3 ellipses. A, 27 into 1 over 3 raised to the power n minus 1. B is 3 raised to the power n plus 2. C is 27 plus 18 into n minus 1. And D is 27 plus 6 into n minus 1. Number 3, the first and the fourth terms of a GP are 4 and 2, 5, 6 over 27, respectively. Find the common ratio. Option A, 2 over 3, B, 3 quarters, C, 4 over 3, and D, 3 over 2. Question 4, the second and fifth terms of a GP are minus 6 and 48, respectively. Find the sum of the first 4 terms. A minus 45, B minus 15, C 15, and D 33. Number 5, find the sum to infinity of 3 plus 2 plus 4 over 3 plus 8 over 9 plus 16 over 27 plus ellipses. A, 1270, B, 190, C, 18, and D, 9. Number 6, evaluate half minus 1/4 plus 1/8 minus 1/16 plus ellipses, bracket open and closes, minus 1. Options are A, 2 over 3, B, 0, C, minus 2 over 3, and D, minus 1. Here are the answers to the exercise. Question number 1, option D. Question number 2, option A. Number 3, option C. Number 4, option B. Number 5, option D. And number 6, option C. We're going to look at general sequences or progressions. We have already discussed arithmetic progression and geometric progression, but there are some sequences that are neither arithmetic nor geometric. They are mixed. So let's take an example of this. Example 1. Find the next two terms of the sequence. 1 over 1, 3 over 2, 7 over 5, 17 over 12, and goes on like that. Specifically, looking at the numerators and looking at the denominators, none of them, taking them individually, is AP or GP. So this is an example of a general sequence. So how do we find the next two terms of this GP? So we will now say, let the next two terms be A over B and C over D. Let's take the numerator where you have 1, 3, 7, 17. Observe carefully here. In this case of the numerator, you have 1 plus 3. Look at me. 1 plus 3 plus 3. It will give us 7. Then we can take the next one. 3 plus 7 plus 7 will give us 17. Then we take again 7 plus 17, and then again plus 17 will give us, if you add it together, that's 34, and that will give you 41. The next one will be taking your 17 plus your 41 and then plus 41 again, in that order. So this is 82, 89, and that is 99. So the two we are looking for, this is A and this is our C. So this one will stand for your A and this one will stand for your C. Then take the denominator, 1, 2, 5, and 12. Following the same method, we have 1 plus 2 plus 2 again to give us 5. Then we take again 2 plus the next one, which is 5, then plus 5 will give you 12. Then the next one is 5 plus 12, then plus 12 will give you 29. Then the next one will be 12 plus 29 plus 29 will give you, this is 58, 59, 60, and that is going to be 70. Let's take that again. This will be 58 plus 2 is 60, and that is 70. So this will give you the B, and then this will give you our D. So write it then in the order of A over B and C over D. We now have our answer, therefore, will be equal to A, which is 41, all over B, which is 29, followed by C, which is 99, all over D, and our D is 70. So these two are the next two terms of the sequence. Example 2. Sn is the nth term of the first n terms of a series, given by Sn equal to n squared minus 1. Find the nth term. Solution to this problem. Your Sn is equal to n squared minus 1. Your S1 will be equal to 1 squared minus 1, and that is equal to 0. So your S2 is equal to 2 squared minus 1, and that is equal to 3. Your S3 will be equal to 3 squared minus 1, and that is equal to 8. We can go on now. S4 will be equal to 4 raised to the power 2 minus 1, and that is 15, 16 minus 1, and etc., etc. Now, if you look at this, in the first term, the sum of the first term, so we now have 0 as the first term. Then the second case, Sn means 0, means 3 minus 0, for you to know the second term, because it is 0 plus a value that gives you 3, and that value will be taking the 0, the first term, from the sum of the second term, followed by your third term, which is 0 plus 3 plus 8 will now give you 8 minus 3. Then the next one, you have added up to this point. To get the fourth term, it now becomes 15 minus 8, and it goes on like that. Now, simply put, this becomes 0, 3, 5, and then this is 7, and so on and so forth. But technically, the 0 here, where n is not equal to 0, the first term, our n not equal to 1, if n is not equal to 1, then we have our terms are 3, 5, 7, and it goes on in that order. So if I told to find the n term of this sequence, so we now have that this is an AP, an arithmetic progression. An AP. The difference between 3 and 5 is 2. The difference between 5 and 7 is 2. So the n term Tn is equal to the first term 3 plus our n minus 1 times the common difference, which is 2. When you solve this one, you are going to have 2n, and of course plus 1 as the n term of the sequence, and that is the solution to the problem. Here's the nugget for the day. If you would thoroughly know anything, teach it to others by trial and error. Exercise number 1. Find the sum of all numbers between 5 and 130 which are divisible by 4. Options A, B, C, D provided. Number 2. The n term of two sequences are Qn equal to 3 times 2 raised to the power n minus 2, and Um is equal to 3 times 2 raised to the power 2n minus 3. The dot here is used as multiplication, please. Find the product of Q subscript 2 and U subscript 2. Options A, B, C, D also provided. You can check your answers. Number 1, option C, correct. Number 2, option A is correct.